Hello, Chem 104 lab students. I'm Professor Meiskens. If you don't already have me for a lab section, I teach in the first two of our 5 lab sections in Chem 104 lab. And before we get started with our next lab module, I just want to kind of give you greetings from Calvin and wherever you might be. We're under very unusual circumstances right now with the university switching to online learning. From my understanding, there's many of the universities and colleges that are in the same situation. And I think we're all going to remember well where we were when this kind of event happened in our lives. We are doing the right thing by following Jesus' command to love our neighbors as ourselves by doing this social distancing and limiting the spread of disease. And so we're going to try to make the best of the situation. We think here at Calvin we have the technology to continue the college education and to keep moving forward, and we'll do that with today's lab. I think there's even possibility that by the focus on trying to do this online is going to give us different ways of thinking about things and probably even helping us to improve the way we approach our labs. We're unfamiliar territory. I've not done things online before, I'll be honest about that. And so we're going to have to both extend and receive grace in the process of carrying this out. So we definitely want to hear from all of you what's working and what's lacking. And we're always available by email, and we'll try to provide other channels that make sense. This is our first experience with online learning for Chem 104 lab. And what we have is a pretty ideal lab to get started with. And I say that for 3 reasons. One is that you've already had some experience making up a solution in the lab. You've also had experience calculating the final calculation of concentration after making the mixture. And you've already done measurements of absorbance in the lab. And so everything that we show you in the lab work will be familiar to you. Later in this module, Professor Tadko is going to show you making the measurements of absorbance as it's written in the lab guide. And so, so you'll be able to see how we make these measurements. So I'm just going to introduce the ideas that we're going to talk about in this lab. If you haven't right now already taken the quiz and done the usual lab preparation, I encourage you now to stop the video and go ahead and do that kind of thing. That's going to really help you to grasp the things that I'm going to talk about in a moment. And also it will be helpful if you're having some way to arrange for the lab guide to be visible. I'm showing it right here, and that will allow you to follow along as well. So what we're going to do in our lab activity today is we're going to support the concept of chemical equilibrium that you're getting in the classroom. And we're going to do it through lab measurements so you can kind of put a different approach to understanding these concepts. So we've chosen an equilibrium that's represented here on the board. And it allows us to observe one of the chemical species by absorbance, because it's colored compound in water. And the other species are colorless. So we're going to control the amount of iron 3 ion and thiocyanate ion that we put in a mixture. And that's going to form this colored compound, the iron thiocyanate complex. And that is how we're going to measure the amount of this new product that's formed. And so we have to talk about using Beer's law to determine that amount of the concentration. We're going to use Beer's law to do that. And let's take a look at this equilibrium. So it's a fairly simple equilibrium involving 2 reactants and a product. And when we write this equilibrium in this way, we are going to be able to write an equilibrium constant for this expression. By writing it this way, we've established a forward reaction, and then we write the double arrows there to represent that it can go backwards and forwards and come to some equilibrium, dynamic equilibrium. So the equilibrium constant is expressed on this page, but I'm going to rewrite it so that it's the way you saw it in class. We're going to have products over reactants, and the concentration of a product, iron thiocyanate concentration, is in the numerator, and then in the denominator we have both reactants, iron 3 ion and the thiocyanate ion. And because the stoichiometric coefficients are all 1 in our equilibrium, then these concentrations are all to the power of 1, and it makes it for a simpler expression for the equilibrium constant. So we are going to be able to determine these 3 concentrations and be able to calculate an equilibrium constant. So what we're going to do to start off is we're going to do one solution where we put a lot of the iron 3 ion in solution and a much smaller amount of thiocyanate. And under those circumstances, all of the thiocyanate is going to be bound up in this complex, iron thiocyanate, which is colored, and we'll be able to measure that amount of absorbance. That, with Beer's law, is going to allow us to determine an equilibrium, molar absorptivity. For later solutions, we're not going to overwhelm it with the iron 3 plus ion. We're going to put more equal amounts of these, and then we can see how much of this complex is formed and use those concentrations to determine its equilibrium constant. Let me scroll down on the page a little bit here, if you follow along, and we can look at some of the solutions that we're going to deal with in this lab. So we have one iron 3 complex, iron 3 ion. It's with the nitrate ion, so it's completely dissolved in dissociated solution. And that's at the highest of these 3 concentrations. It's 4 times more concentrated than this second iron 3 solution, and it's 80 times more concentrated than the thiocyanate solution. It also has a spectator ion of potassium. So nitrate and potassium are spectator ions in this equation. So you can easily see if we make mixtures of its most concentrated solution with the thiocyanate, that it is going to have an excess of the iron 3 plus. The latter solutions will be made up of combinations of the last 2 of these. Now, if you'll go with me to the second page. Part A is preparing. Okay, here we are on the second page of our lab guide, and I'm going to go to part B, which talks about Beer's law, and I'm going to zoom in on this equation here. This tells us how absorbance is related to concentration, and this quantity epsilon here is the molar absorptivity, and L is the path length through this cuvette, and that is normally 1 centimeter. So knowing these 2 constants, epsilon and the 1 centimeter path length of the cell, allows us to directly relate absorbance to concentration. So for part A, we're going to actually have an idea of knowing the concentration of our complex, our iron thiocyanate complex, and we're going to calculate epsilon. So that looks like, if I move this over and make myself a little space, what we're going to do for part B is solve for epsilon. So epsilon is equal to absorbance divided by L divided by the concentration of our complex. And we're going to measure that in the lab. We're going to know that L is 1 centimeter, and we're going to know what the concentration of our complex is and be able to calculate epsilon. Now let me talk for a moment about units of this. It's not explained well in the lab guide. Absorbance is unitless. And so the units of epsilon are 1 over centimeters times molarity. So inverse centimeters, inverse molarity are the units of epsilon. When we get to the next part of the lab, you're going to be measuring an absorbance, and you want to use that to find the concentration. In that case, we need to use this value for epsilon from this part B, and we will carry that forward. So if I make a little more space here, in that case, we're going to want to find the concentration from the absorbance divided by the epsilon value, molar absorptivity, times the path length. And when we measure absorbance, we know this value from part B. We can calculate the amount in concentration of the iron thiocyanate complex. So we'll be using Beer's law in that way in this lab, and Professor Tatko is going to show you the measurements of those absorbances. So when you have questions, we want you to feel able to look for answers. Don't allow yourself to get stuck for a long time. Send a question and then wait for an answer to come. And we'll try to provide forums for that to become easy. So I wish you well, and I hope you are in a good place and that you stay well.